All right, today's lesson we're going to be looking at polyatomic compounds. So the bell ringer for today is review from yesterday. It says write the formula and the name when we combine hydrogen and iodine. So our first step is to write out the cation. So the cation in this case is hydrogen. Hydrogen has a +1 charge. And then let's go ahead and write out the anion. The anion is iodine. Iodine has a charge of -1. So in this case, it is a 1-to-1 ratio. We don't need to add any subscripts. So when we write the formula out, remember, we do not include any of the charges. So we end up with just H and I. Did that on purpose. I wanted to say hi. When we write the name out, we write the hydrogen out as is, so hydrogen. This is our cation, and remember our cation, we just write it out, don't change anything. And then for the anion, we are going to write out the name, but instead of iodine, it's going to be iodide. Hydrogen iodide. The ending when we combine these is always IDE. So yesterday we talked about monatomic, and that's where we're forming just one atom. They're formed from one atoms. So we have bromine by itself, oxygen by itself. When we add these together, it's just 1 and 1. When we talk about polyatomic ions, we're talking about groups. These can have 2 or more atoms. The examples below, we have 2 atoms that are being combined. These polyatomic ions can't be separated or changed. You kind of get the whole package. And the charge, so in these examples, these charges apply for the whole unit. So it's not just a charge on oxygen or sulfur. This -2 charge here applies to the whole thing. Same thing over here, this -1 charge applies to the whole thing, not just the oxygen or the nitrogen. It's the whole package. In your chem resource packet, you have a list of common polyatomic ions. They are listed with the name as well as the formula. Okay, so look at this one right here. We have sulfate, and the formula is, I'll write it a little bit bigger, SO4, and the charge is -2. So all of the polyatomics are there. Now I want you to notice that these are both anions. Not sure what happened to my pen here. So they're both anions and cations. So we do have some polyatomic cations with a +1 charge, but most of these are anions. When we write our formulas out, we always start by writing the cation first, followed by the anion. Same format that we've been using. We need to determine the charge of both. Then, if necessary, we need to make some changes by adjusting the charges. So we're looking at the ratio here. And then finally, if you need more than one polyatomic ion, it must go in parentheses, and this is important. You'll see these in a couple of examples. So for our first example, we have magnesium and nitrate. So magnesium is Mg, and the charge on magnesium is +2. Our anion, nitrate, if you reference your table, you will see that nitrate is NO3, and it has a charge of -1. So just like yesterday, we look at the exponents here. So I have a +2 and a -1. I need to add a 2 here to get this to balance out. And when I do that, I'm going to put parentheses around the entire thing here. So when I write this out, again, when we write our formula, we write it without the charges. So I have Mg, and then in parentheses, the whole thing, NO3, with the 2 out here. Let's look at another one. In our second example, we have sodium sulfate. So let's start by writing our cation. Sodium is Na with a +1 charge. Sulfate is SO4 with a -2 charge. So just like last time, we look at the exponents and kind of compare. So we're going to need another sodium to balance this out. So when I write out my formula, I have Na2SO4. Let's look at another one. Here's aluminum hydroxide. So aluminum has a +3 charge. That's our cation. Our anion is OH with a -1 charge. So looking at our exponents here, in order to get this to balance, I need 3 OHs because we have a +3 charge and the OH is only -1. So I need 3 of those to balance everything out. So when I write out my formula, it's going to be aluminum, and then in parentheses, hydroxide, and I need 3 of those to balance the equation out. In this final example, aluminum chloride, oh, this is supposed to be ammonium. Let me just make that correction. Ammonium. Ammonium chlorine. Okay, so ammonium is our cation. Ammonium is one of those rare cations that is polyatomic. So it has a +1 charge. Our anion in this case is chlorine, which is Cl with the -1. So this is a 1-to-1 ratio. So this will be NH4Cl. Don't have to change anything, don't have to do parentheses because it's a 1-to-1 ratio. We have a +1 and a -1. Everything's cool. All right, now when we do the naming is super easy because we never change the name of the cation and we never change the name of the polyatomic. So let's look at a couple of examples. Okay, so sodium, and the polyatomic part right here is going to be, if you look at your table, nitrate. Sodium nitrate. Let's look at another. Okay, so our cation in this case right here is ammonium. And our polyatomic part at the end is hydroxide. Okay, here's another one. We have calcium. And the second part of this is going to be carbonate. One last example. So even though there's a 3 here, doesn't matter. This is still barium. Same thing on the second part, even though there's a 2 here, this is still phosphate. All right, these are pretty straightforward in my opinion. So you should have a sheet of practice problems. I'd like you to complete either the even or the odd problems. Certainly you can work through all of them for extra practice, but I'd only like you to complete the even or odd in class. If you don't finish, that would be homework, but I'm pretty confident that you can get it completed in the amount of time you have. Your exit ticket for today is to write the formula for ammonium nitrate. Please turn in when finished. And most importantly, have a great weekend.